Let's go ahead and highlight the lean. And notate on here, that is our lean, which is actually called a slant height. Okay, now let's look at the formula chart and list out all three formulas. So Nolan, give me what the formula says for lateral area.
Lateral area cone.
Mm-hmm.
Lateral area pi r l.
Good. Bryce, what about surface area?
Pi r l plus pi r squared.
Pi r squared. Does it make sense that it's got one area of the square instead of two of them? Because it's a cone, okay? Kyla, what about the volume?
Pi r squared times height
Over 3. So I'm going to prove one of them for you. In case you're deciding to memorize a formula, this may be for you. Write this if you want. You don't have to write this piece. Let's say you know the lateral area of a pyramid, and you're like, well, I really forgot the lateral area of a cone. There's a way to formulate it. The perimeter of a cone is always a circle, right? And the circle formula for circumference is 2 pi r. And let's copy everything back. Lean was there, 2 was there. What can I cancel out? Did I really get to the formula there?
Yeah.
Yeah. Just like when we did the prism to the cylinder, you can do that with the pyramid to the cones. Okay? All right. For number 1, Jackson, let's read.
Find the radius of the base of the right cone.
Okay. Let's go ahead and highlight the right triangle that this makes with the lean, radius, and the height. And I should actually connect this and say that's my R. So if I were to pull this out, just to make the picture simple, 34 is my hypotenuse. The height is 30. If you're tapping, stop. The radius is what we're looking for. What should we use to find the radius? Pythagorean, and the square root of 34 and be miserable, right? Let's kind of recall Pythagorean triple. We had 3, 4, 5. What else do we have? 5, 12, 13. These were the 3 that I asked you to memorize. The third one started with 7. What is it? 24, 25. Now, what's not cool about this problem is that it's not using one of the triples that I asked you to memorize. It's wanting the 4th one. Do y'all remember the 8? Maybe? 8, 15, and 17. So 8, 15, and 17 underneath it, let's write out 34 and 30. So we are doing what? They're multiples of 2. So that means the radius must be how many? 16. If you don't remember this, your default will be Pythagorean theorem, that I don't want to do. Is everyone good with that? Okay? All right. Let's move on to number 2. On number 2, cross off something for me. We are not using a calculator. So I'm going to make this number pretty. Let's make the radius 3. And let's make the lateral area 40, let's do 45 pi. Sam, let's read.
The lateral area of Rusty's waffle cone is 45 pi centimeters squared, and its radius is 3 centimeters. Find the height of this waffle cone. Don't include the estimate.
So let's draw this. Here I have a cone with a circle base. Doesn't have to be perfect. So here's my lean, and there's my radius that's perpendicular, and here's our height. What area is it asking us to find? The lateral. And the lateral was pi r l. So just by looking at this, we know the pi, we know the radius is 3. Do I know any information about the lean?
No.
Could I find the lean?
Yes.
How can I find the lean? It's asking us to find the height, right? So then we can go ahead and plug in 45 pi because the lateral area is 45 pi. What can I cancel out on the left and the right? Pi's are gone. What is 45 divided by 3? 15? 15? So if I know my lean is 15 and my radius is 3, Can I use Pythagorean theorem? Is this one of the triples? Sadly, it's not. So let's find the h. We have 3 squared plus h squared is equal to 15 squared, which gives me 9 plus h squared is 225. Is that right? So our h squared must be, how many is that? Minus 9. 214 or 216? 216. When we square root, we're not typing this in the calculator, obviously. Let's go ahead and simplify this, Mark. 2 times what? 108. And then 2 times what? 50. And then 2 times again? And when I see 27, I'm going to do a shortcut. 3, 3, and 3. Let's circle our pair. We have a set of 2. We have a set of 3. And then the next 2 we do not have sets of. So do I add them and multiply them? What do we do? Multiply. So we have 6 radical 6. And our units for this one is centimeters. And that is our height. And voila. Okay, let's go on to the back. On the back, let's do number 3 and number 6. Okay, let's do number 3 with the partner. Talk to your neighbor. To your neighbor.
Or we need to do this multiply 24 by the so we have the okay, so we have the radius. So this radius is 12 pi.
It's 24 pi.
Pi squared is 144. Right? The radius is what?
12, right? Because 2 pi r is circumference.
Yeah, and then exactly. So R would be
David's working,
12 squared
kind of. Okay.
16 squared equals
It's the
L square root 45
Wait, no, it's not. 3. Oh, no, it's not 22.
It is, but like, what's going on?
Pi r. 16 squared. That's, well, by 20. 200.
Is it 216?
No, 15 squared.
Oh, that's 225.
Yeah, 16 squared is what?
225. 15 squared?
No, 6.
Mm,
256.
something with the 6 at the end. I'm going to double check. 16 squared, David? 256, yeah. Who had that? I heard it. Very nice.
No, yours is 240. I said 26.
I literally I ran yell out right now.
That was little Charlie bad.
Mark, are you done with the surface and the lateral?
Of course.
No, it's not.
It looks empty.
I haven't started. I don't know where to start.
Start by the picture first.
How do you draw a
Draw circle with 10 times.
Like a tent on it, yes. Like a teepee.
2 lines.
like that?
Back.
Trash.
Yo, holy cow.
Did y'all start with the circumference?
Yes.
So circumference is 2 pi r. They gave us a circumference is 24 pi. So when I plug in 24 pi on the left and leave the right, the radius really in the end becomes how many? 12. So I'm going to plug in 12 here.
12 squared is 144.
Then if I know 12 and 16, the lean has to be what? Think of 3, 4, 5, 20. Should I write that out? The 3, 4, 5? Maybe? Let's write it out. Here's 3, 4, and 5. Here's 12, 16, and blank. And they're multiples of 4, so 5 times 4 is 20. Okay, let's write the formula for lateral area. We have pi r L. And we know the lateral area is pi, the radius 12, the lean is 20. The number's kind of nice. Isn't that 240? Pi? Yep. And then for surface area, we have pi r L plus pi r squared. I know this piece, so I'm going to write 240 pi. Someone's talking over me. What is 12 squared? So we have 144 pi. We also have 240 pi. Can I combine like terms on this one?
Yes.
How do I know? They both have pi's. So 384 pi feet squared. Oh, that's feet squared. Oh no. Okay, if you're ready for the last one, thumbs up. I'm going to modify it. I want you to change up number 6. Instead of 25 pi, let's do 20 pi, just because when I half that, it's going to be a not so pretty number. Okay, Colton, let's read our last one.
Find the volume of a cone with a base circumference 25 pi inches and a height that is 2 inches more than twice the radius. Leave answers in terms of pi.
Read that again.
What? Oh.
Let's try it
Find
again.
The volume of a cone with a base circumference of 20 pi inches and a height that is 2 inches more than twice the radius. Leave answers in terms of pi.
Thank you. So we know our circumference is 2 pi r. I gave you circumference of 20 pi. Then what is the radius? 10. And then it says the height is 2 inches more than twice the radius. What is twice this?
20?
Add 2 more.
22.
So that means our height is 22. So now if we look at the volume formula, we have pi r squared, h all over 3. Then we have pi, 10 squared, the height is 22, divided by 3. Could we just do 100 times 22 right off the bat? What is 100 times 22?
2,200.
Is it 2,200?
Wait, what'd you say? 10 times 22?
We're doing 10 squared is 100.
2,200.
Are we okay with that? 2,200?
Yeah.
All divided by 3. Is 3 divisible? Leave it just like this. So we have inches squared. Oh, cubed. I was almost back. All good?